Assalamualaikum and hi everyone. Now we want to learn about topic 7, normal distribution. Let's proceed to lecture 104. For this topic, we have two subtopics. There is 7.1 introduction and 7.2 normal distribution. For 7.1 introduction, we will learn how to define the normal distribution when X is normally distributed at mean and variance. Let's look at the introduction to the normal distribution. Normal distribution is one of the most important distributions in statistics. If a continuous random variable x has a normal distribution with mean, the symbol is mu and the standard deviation sigma, then we write x is normally distributed at mean variant. With these two parameters. So we will have a bell-shaped curve, with mean and standard deviation. Now let's look for the normal distribution bell curve. The normal distribution is a continuous probability distribution and often has a bell-shaped curve because the graph of its probability density is equally distributed, looks like a bell. So for this topic, we will use normal distribution bell curve to solve our examples. Now let's look at the properties of the normal distribution or bell curve. So this is the bell curve. The normal distribution curve is symmetrical on both sides of the mean. So the right side of the center is a mirror image of the left side. The area under the normal distribution curve represents probability and the total area under the curve sums to 1. The tests are asymptotic, which means that they approach but never quite meet the horizon or the x-axis. For a perfectly normal distribution, the mean, median, and mode will be the same value, visually represented by the peak of the curve. This is the daily life examples of normal distribution. We can use normal distribution for height of the population, income distribution in economy, birth weight, and students' average report. For 7.2 normal distribution, the learning outcomes are standardized in a normal random variable from X with normally distribution mean and variance to Z with normally distribution 0, 1. Determine the probability using the standard normal distribution table. The standard normal distribution. The normal distribution is determined by two parameters, the mean and the variance. A normal distribution with mean 0 and the standard deviation equals to 1 is called the standard normal distribution. So this is the bell curve, for standard normal distribution, where mean equals to 0, will be in the middle. The Z values or Z scores are the unit mark on the horizontal axis of the standard normal curve. The Z scores is positive if the value lies above the mean and negative if it lies below the mean. The continuous random variable Z is used to represent the standard normal random variable Z with normal distribution 0 and 1. To standardize a normal random variable X to a standard normal random variable Z, we will use this formula. Okay, z is equals to x minus with mean divided with standard deviation. D is for normal distribution and z score is for standard normal distribution. So x is the raw score, okay, mu is the mean, and sigma is a standard deviation of normal distribution. The standard normal table can be used to find the area under the standard normal curve. Okay, the area represents the probability. The table that will be used in this topic is more than or equal standard normal table. Determine the following probability using standard normal distribution table. Okay, note that Z is normally distributed at 0, 1. So mean is 0 and 1 is our variance. For A, we want to find PZ greater than 1.2. Okay, let's draw the bear shape. First, we write mean in the middle, mean equals to 0. Then, we write 1.2. So, 1.2 is on the right side because it is positive. Then, we shade the area. So, the area, we look at the symbol for Z. So, in this case, Z is greater than 1.2. It means that our area is on the right side. So please remember that our table represents probability for Z greater than Z. So when we read, okay, the table at 1.2, it means that we will get, okay, the value for PZ greater than 1.2. Okay, let's read the table. Okay, so first, okay, we read at the first column on the left side, 1.2. This is the value. Okay, so for in this case, 1.2 is same as 1.20. Okay, 0. So our answer will be 0.1151. So we can write that PZ greater than 1.2 is equals to 0.1151. So B is PZ less than 1.2. Okay, same as previous example. Okay, in the middle is mean, 0, and 1.2 is on the right side. But for this question, the symbol is less than. It means that our area is on the left side. Okay, please remember, okay, when we read at 1.2, we will get this area. Okay, the area greater than. So how we can get the shaded area? Okay, so we can use, okay, 1 minus, okay, PZ greater than 1.2. Okay, we minus, so that we can get the shaded area. So from the table, okay, we can read that 1.2 is 0.1151. Okay, same answer as the previous example. So 1 minus 0.1151 is 0.8849. For C, we want to find PZ less than negative 1.85. So first, let's draw the bear shape. 0 in the middle. Then negative 1.85. Because it is negative, okay, the value is on the left side of 0. And the symbol is less than. That means the area is on the left side. So, our table is only for PZ greater than, okay, Z. So, Z is always positive. Okay, we cannot read it if the value is negative. Because the curve is symmetry, Okay, we can reflect the value of negative 1.85 to the left side. Okay, we shade the same area. Okay, because it is symmetry, that means the area is equal. Okay, have the same values. So from here, we can read from the table and get this value. We can conclude that Pz less than negative 1.85 is equal with z greater than 1.85. Okay, it gives the same area and the same value. Okay, let's read from the table. Okay, we want to read at Pz greater than 1.85. Okay, same as the previous example. Okay, we read from the column on the left side, 1.8. Okay, 1.8 is here and 85. Okay, so the second decimal is 0.05. So our answer will be this value, 0.0322. Okay, for D, we want to find probability when Z greater than equals to negative 1.85. Okay, let's plot the value. So negative 1.85 is on the left side. Okay, for this question, the symbol is greater than, and equal. The area should be on the right side. Okay, we reflect to 1.85. So the area that will be the same as the previous one should be on the left side. Okay, this area. So please remember the area when we reflect the value should be the same, as the original one. So if we read the table at 1.85, we will get this area. Okay, greater than 1.85. Okay, so to get the area, on the left side, so we have to use 1 minus Pz greater than and equals to 1.85. Okay, we can take the value we get from the previous example in part C. So the value is 1 minus 0.0322. So our answer should be 0.9678. E is for probability when Z between 0.2 and 0.5. Okay, let's shade the area. 0.2 and 0.5 both are on the right side. D is the area. Okay, when we read at 0.2 from the table, we will get this area. Okay, Z greater than equals to 0.2. So to get the area in the middle, so we have to minus this area. Okay, we have to minus this area. So we can write that, our operation is Pz greater than 0.2, and then we have to minus with Pz greater than 0.5. Okay, let's read from the table 0.2 and 0.5. Okay, so 0.2 is here, 0.20. Then the value for 0.50 is 0.3085. We take these two values, to solve for the question. 0.4207 minus with 0.3085. So your last answer should be 0.1122. For this question, we want to find the probability of Z greater than negative 2.1 and less than negative 1.5. By using the curve, the values will be on the left side because it is negative, negative 1.5 and negative 2.1. This is the area. We cannot read the values from the table because both are negative. So we reflect it so that it will be on the right side. 1.5 and 2.1. So we can use pz greater than 1.5 minus with pz greater than 2.1. Okay, let's read the value from the table. 1.50. Okay, we read the table at 2.1. So the value is 0.0179. Okay, let's calculate the value. It will be 0.0668 minus with 0.0179. We will get 0.0489. We want to find probability of modulus Z greater than 2.64. Okay, we have to use the definition for absolute values. So we will get, okay, Pz less than negative 2.64 union with Pz greater than 2.64. Okay, let's use bell-shaped curve. 0 in the middle, 2.64 on the right, and negative 2.64 on the left. So the region, okay, greater than in the right side, and less than negative 2.64 on the left side. So actually these two areas is equal or have the same values. So we can write as Pz greater than 2.64 plus with Pz greater than 2.64. Okay, because the area give the same values. Is equals to 2 times Pz greater than 2.64. Okay, let's read the table. Okay, here is 2.6. Okay, 0.04. The value should be 0.00415. So the value should be 2 times, okay, 0.00415. Your answer should be 0.0083. We want to find the probability when modulus Z less than or equals to 2 over 3. We use the definition. Probability of Z is from negative 2 over 3 until 2 over 3. Okay, we use the definition. Okay, let's find the area using the bear shape. Negative 2 over 3 on the left side and 2 over 3 on the right side. Okay, we can change it into decimal. Okay, because in the table it's only in the form of, okay, decimal. Okay, 2 decimal places. So the area should be in the middle. Okay, it's from negative 2 over 3 to 2 over 3. So how can we find the area? Okay, we can use 1 minus with the area on both sides. So 1 minus Pz less than equals to negative 0.67. This area. And minus also with Pz greater than 0.67. Okay, then we will get, okay, the area in the middle. For this area, Pz less than or equals to negative 0.67. It has the same value, okay, with the probability of Pz greater than or equals to 0.67. Okay, so we can change the symbol. Okay, it will give us the same value. So it will be 1 minus 2 Pz greater than or equals to 0.67. Okay, then read the table. Okay, 0.67 should be, okay, 0.07 is here and the answer should be 0.2514. Okay, let's proceed to the calculation. So 1 minus 2 times 0.2514, we should get 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. 0.4972. If Z is normally distributed at 0, 1, find K such that A is Pz greater than equals to K equals to 0.3745. So for this type of question, okay, we will look at the symbol, okay, this symbol, and the value of probability. So for Z greater than equals to K, it means that our area will be on the right side. And for the value of 0.3745, it is less than 0.5. Okay, if you still remember, for normal distribution, okay, it's symmetrical, and each side, okay, the area is 0.5. So for 0.3745, okay, so this is the area, 0.3745. It's less than 0.5. So we want to refer table 3 at value 0.3745. So we will find the value, okay, in the middle. So we can get the value of 0.3745 for Z 0.32. Okay, we take the values. So we can write Pz greater than equals to 0.32 is equals to 0.3745. Then we can equate the value. So therefore your K will be equals to 0.32. For B, we want to find Pz less than K when it is equals to 0.35. So for this one, the symbol is less than. It means that the area shaded will be on the left side and the value is 0.35. So this is the area for 0.35. Okay, now we can read 0.35 from the table. For this one, we will refer to table 4. Okay, for table 4, we refer whether in the first or third column. Okay, we find the value 0.35. Then we will get the Z score 0.4853. So we can write Pz less than 0.3853 equals to 0.35. But for this one, we need to put negative in front of the value because our K is on the left of 0. So we will get K equals to negative 0.3853. For C, we want to find Pz less than equals to K when it is equals to 0.6217. The symbol is less than and the value is 0.6217. So for this one, the probability, okay, values is greater than 0.5. So our K will be on the right side. And this is the area that will give us the value of 0.6217. So for this question, okay, because our table is Pz greater than equals to Z, okay, we will get the value by using P minus Pz greater than equals to K equals to 0.6217. Simplify the value, so Pz greater than equals to Z is equals to 0.37. 0.3783. So 0.3783 is this area. Okay, now we can refer to table 3. So we find the value 0.3783. Okay, this is the value. So the z-score will be 0.31. So from the table we get pz greater than equals to 0.31 is equals to 0.3783. Therefore, the value of k is equals to 0.31. For D, pz greater than k is equals to 0.8. The symbol is greater than and the value is 0.8. Okay, so 0.8 is greater than 0.5. So it starts on the left side. So to get this area, okay, we have to use 1 minus, okay, this part. So we can get, okay, the value by using 1 minus, okay, pz less than k equals to 0.8. So we want to minus, okay, this area is pz less than k. Simplify the value. So pz less than k is equals to 0.2. Now, we want to find the value of z from table 4. Okay, we want to find the value of 0.2. The z-score is 0.8416. So, pz less than 0.8416. Don't forget to put negative because k is on the left side. Okay, this equals to 0.2. So therefore, k equals to negative 0.8416. So that's all for lecture 1. We will continue on lecture 2.